Hello, good evening students. How are you all? Hi Shillong Center, Presidency College and hi Kohima Center. Okay, so in the last class we have started the sets and we have discussed some things about the set, the basic things we were discussing, like what are sets, what are the form in which we can represent set. We have discussed the set builder form, we have discussed the roster form, and we have done some questions on conversion from one form to another form, and then we have done the types of set like empty set, singleton set, and different types of set we have done, and some questions on them also, right? So today we are going to discuss about the subsets and power sets and then Venn diagrams. So let's start with the subset. Subset we have started in the last class also, but let's start with the beginning again. So note down the heading, this is called the subset. So we will say the definition of the subset goes like this: if A and B are two set and if every element of A is an element of B, if every element of A, whatever element are in there in A, if that is the element of B also, we will say A is a subset of B. And how we can write this one is, the notation for writing this one is this symbol, A is a subset of B. So we can say, or we can also say, if A is a subset of B, if and only if there is a member A which belongs to A, it implies A also belongs to B. This symbol is for used to belongs to. If A is a element of A, then it implies that A is also element of B and vice versa. So basically, whatever number of elements are there in A, whatever elements are there in A, if those same elements are there in B also, we will say A is a subset of B. Now, 2-3 points we have to discuss. There are two types of subset, proper and improper. So what are the proper subsets and improper subsets? So proper subset are those subset, we can say it contains some but not all elements of original set. It contains some of the elements but not all the elements of the original set. That type of subset is called proper subset. And opposite of that one, improper subset will be that subset which contains all elements of original set. So these are the two types of subset. Second thing, 2 points we can discuss over here, we can write. The first point is, every set is a subset of itself. Every set is a subset of itself. And second point, null set or empty set is a subset of every set. The empty set, the void set, the null set, that null set is a subset of every set and every set is a subset of itself. These are the two main points. And we can also say that empty set is a proper subset, because you know proper subset means which does not contain all the elements, which contains some of the elements. So empty set is a proper subset of a given set. So these are the 3 points, and one more point which we can note down: the total number of subsets. So the total number of subsets of a set containing n elements. If there is a set in which there are n elements, then the number of subset would be 2 raised to the power n. These are the total number of subset. It means if there is only one element, there will be 2 subset for that one, and if there are 2 elements, there would be 4 subset. So basically the minimum condition is that that point we have discussed, every set is a subset of itself and null set is a subset of every set. We can relate it with this one, like if I ask you the divisors of any number. So 1 is always the divisor of any number, and that particular number is always divisor of that number. So those two are the minimum divisors. Similarly, these two subsets will always be there for every set, null set and the subset, the set itself. These two will always be the subset of that particular set. So if the total number of subsets are 2 power n, we can say that the proper subset would be, because proper subset are those which does not contain all the elements. If it contains all the elements of the original set, it becomes improper. So proper subset would be just subtract 1 from this one. So that would be 2 power n minus 1. So suppose let's take an example. Any doubt till now? Shillong Center and Presidency. This is the thing which we have discussed in the last class. Shillong Center, any doubt? Okay, that's great. So try this one example. Two finite sets you know, which has the fixed number of elements which we can count. Two finite sets have m and n elements. In one set there are m elements, in another set there are n elements. Total subsets of first set is 56 more than second set. Find m and n. So this is the example. It says there are two finite sets, and in the first set there are m elements, in the second set there are n elements, and it also says that the total number of subsets in the first set is 56 more than the total number of subsets of the second set. So we have to figure out what would be the values of m and n. So you know, if there are m elements, then the total number of subset is given by 2 power m, and if there are n elements, the total number of subset is 2 power n, and the difference of these two is going to be 56. This is the question. Now only this condition is given and we have to figure out the value for m and n. So you can see that only one equation is there. So we have to solve it by assumption, or you can say by the hit and trial method. So using hit and trial method, what you can do over here, either you can think of two numbers which are in the power of 2 whose difference is 56, and then you can figure out, because these two numbers are in the power of 2, like one of the way is by the hit and trial, like this you can do 2 power 1 is 2, then 2 power 2 4, then 8, 16, 32, 64 and 128, like this. Either you can do like this, and you can see which of the numbers gives a difference of 56, or so if you go it by this method, if you see between which two number we have a difference of 56, you can see between this 8 and 64. This 8 and 64 differ by 56. So it means you can say 2 power m is, because you can write like this should be 64, this should be 8, and the difference is going to be 56. So if it is 64, then 64 can be written as 2 power 6 and 8 can be written as 2 power 3 is equal to 56. So you can say m is equal to 6 and n is equal to 3. This is one of the way to solve this question by using the hit and trial method. Or again, another method is also the hit and trial method, but what we can do over here from this original equation, if you take 2 power n as common, so if you take 2 power n as common, it will be like this: 2 power m divided by 2 power n minus 1, that is equal to 56, and this can be written as, according to law of exponent, 2 power m minus n. Now these are the product of two numbers, one is the 2 power n, second one is this number. So what we can do, we can convert this 56 into product of some numbers in the same way. So we can break it like this, we can write like this, 7 into 8 is 56. So by using the hit and trial, we can do like 7 into 8 is 56, and one of the number should be in the power of 2, because this number, you can see 2 power n, this is in the power of 2, and another is not in the power of 2. So in the factors of 56, one of the number should be in the exponent of 2. So you can either take 2 into 28, you can take 8 into 7, or 16 is not a multiple, neither 32 does not divide 56. So we can take this one, 8 and 7. So if you take 8 and 7, so you can write this 8 as 2 power 3, and this 7 can be written as, in terms of 2 power 3 minus 1. So you can equate it like this. So if you compare 2 power 3 and 2 power n, you can say n is going to be 3, and if you compare these two, you can say m minus n is going to be also 3. If n is equal to 3, m is going to be 6. So these are the answers, value of m and n, 6 and 3. I hope you are getting this. Shillong Center, is it clear? Presidency? Is this clear, Shillong Center? Please give your responses, whether this example is clear or not. M minus n is equal to 3, you can compare on comparing these, this part and this part when we have compared. So this is 2 power 3 and this is 2 power of m minus n. So on comparing, m minus n is equal to 3 and n is already 3. So if you put n is equal to 3, you will get m is equal to 6. Got it? Okay, perfect. So basically we are discussing subsets. So you can say, what are the subsets of real numbers? So what are the subsets of real numbers? So you can say there are many subsets of real number. The set of all natural numbers, because every number which is a part of natural number, it is a part of real number also. So you can say set of all natural number, n is a subset. Similarly, the set of all integers, you can say z is also the subset. Or you can say the set of all rational numbers. In the starting I have told you rational number we will denote by q. So the rational numbers are also the subset of real number. And the set of all irrational number also, these are also the subset, and let us say it is denoted by t. So the set of all irrational number also are the subset of this one. So we can write it like this. We can say that n, since it is a and how we can relate this one, you can see that natural numbers are also the subset of integers. So we will write the symbol like this, n is a subset of Z. And one more point you can see over here, I have not included the equal to sign in the subset because it is a proper subset. To denote proper subset, we will always use only this symbol. This equal to symbol will be used when it is that original subset is also included in the subset. That's why we have not used the equal to sign. So n is a subset of, you can say proper subset of real number, because all the you can say all the integers are not natural number, but all natural numbers are integers. Similarly, so n is a proper subset of Z, and you can say integers, and integers are proper subset of rational numbers, and rational numbers are proper subset of real numbers. So we can only say proper subset because it doesn't contain all the elements. That's why we have used the symbol only this subset sign, which is the proper subset sign. And you can also say if it is not a subset, so you can say natural numbers are not a subset of this irrational number, because we can make the symbol this one, and we can cancel out this one also. It means that natural numbers are not a subset of irrational number. So this is the way in which we can write the proper subset. Now, after this, we have the terms intervals. How we can write the numbers in the interval form. So to write the number in the interval form, there are three types of interval. One is the closed interval, one is the open interval, and one is the semi-open or semi-closed. Now, what do we mean by this open interval and closed interval and semi-closed or semi-open? So if we talk about closed interval, it means suppose there are two numbers A and B, and A is less than B, B is greater and A is smaller. So the closed interval says the set of all real numbers which is denoted by X, that X lies between A and B. It means that X is greater than or equal to A and X is less than or equal to B. This is known as the closed interval, and this closed interval is denoted by, we can also write it like this, A comma B and this square brackets. These square brackets indicates that the numbers are from A to B, including A and B also. It means if I say 2 comma 5 and the square brackets are there, and if I am talking about only the natural numbers, so it means the minimum value is 2 and the maximum value is 5, including all the natural numbers between 2 and 5. So you can write it like this, 2, 3, 4, 5, if I am talking about the natural numbers. If I am talking about the rational number, so you know between any two rational number there are infinite rational number, so the answer is going to be infinite. Similarly, on the number line, how we can represent that one? This closed interval is represented like this. Just draw a number line, arrows on both the ends. What is the lower limit? Lower limit is from where it is starting, and the upper limit, so this is 2 and this is 5. So with the help of this line, make two circles over here and fill it with dark circles, you can say. So this line indicates that we are talking about from 2 to 5, and 2 and 5 both are included. That is the meaning of this closed interval. Similarly, if we talk about the open interval, now since the closed interval, you know what is a closed interval, now you can relate the open interval. So open interval means suppose there are two numbers A and B, and A is less than B. Now the set of all values of X, if X lies between A and B and B are not included, you can see I have made the inequality sign. X is greater than A and X is less than B. So between A and B, whatever is the numbers are there, that should include in this X, excluding A and B. So, and in order to write this one, we will write it like this in terms of intervals. we can write it like this: A comma B. So A comma B and the parenthesis should be there. So you can see this one, this curve bracket, you can say these are also known as parenthesis. So parenthesis should be there. It means that we are talking about all the numbers from A to B excluding A and B. So in the same way, if I write like this 2 comma 5, and suppose if I am talking about the natural numbers, so you will say all the natural number between 2 and 5 excluding 2 and 5. So after 2 the natural number we have 3, 4. Only this will be the answer. We will not include the 2 and 5. This is the meaning of open interval. And open interval on the number line, it is noted by this, like if this is 2, this is 5. So just make a circle over 2, circle over 5 and join it by a line. And these circles should be empty circles, you can say. It should not be filled one. So this indicates that we are not including 2 in our calculation, neither 5. All the numbers between 2 and 5, this is our solution. This is known as open interval. And now you can relate what is semi-open. Semi-open or semi-closed. So now semi-open or semi-closed interval will be like which is open on one side and closed on another side, or vice versa. So you can write it like this: A comma B and square bracket. It means from A to B all the numbers, but we are not including A, but we are including B. So on the number line you can write it like this: A, B, only circle on A and a dark circle on the B. That is the meaning. Similarly, you can also write like this: A, so this time the square bracket is on A, so it will be dark circle on A, and you can say the open circle, the other not dark one, the open circle on the B. This is the meaning of the semi-open or semi-closed. So if I talk about, if we take an example like this, let's say 2 comma 6. So you can see, and if I am talking about write the natural numbers in this interval. So natural numbers from 2 to 6, not including 2 but including 6. So you will write it like this: 3, 4, 5 and 6. Similarly, if we draw like this, so it means we are including 2 this time. So 2, 3, 4 and up to 5 only. So that is the meaning of semi-closed or semi-open. So these are the three types of interval: semi-open, semi-closed, open and completely closed interval. And one more point in this interval you can note, that is called length of any interval. Length of any interval, whether it is open, closed, semi-open, semi-closed, whatever it is, like it can be like this, it can be like this, it can be like this, or it can be like this. Whatever is the interval, the length of interval is noted by upper limit minus lower limit, B minus A. That is the length of any interval. So these are the three types of intervals, and the length of any interval is B minus A. Any doubt in this one, in the concept? Is it clear till now? Okay, that's great. Shillong, Tatso, Presidency, any doubt till now? Honey, B minus A is only the length of the interval. Like let's take an example. Suppose our interval is like this, and if I ask you what is the length of this interval, so the length of this interval, you will say length is 6 minus 2, which is 4. So 4 is the length of the interval. Or if I say minus 2 minus 12, and if I ask you what is the length, so you will say minus 12 minus of minus 2, which is -10 is the length of the interval. b माइनस ए का कोई यूज नहीं, वो पैरेंथेसिस का कोई यूज नहीं, यहाँ पे केवल वो सब्ट्रैक्शन बता रहा है आपको द लेंथ. Getting it, Shillong? Okay then. Now, note down the next one. That next type of set after a subset in subset, that is called universal set. Now, universal set is basically means, suppose we are talking about the natural numbers. We have some sets of natural number like 1, 2, 3, 4, 5, 6, 7, 8, 9. So, set of all natural numbers, that will be called as the universal set for that set. Similarly, if I talk about the coordinates 2, 3, 4, 5, then set of all the coordinates, that will be called as the universal set for that coordinate. If I talk about the students, some boys of class 8th, girls of class 10th, and boys of class 9th and girls of class 9, then set of all students in that school, that will be the universal set. So basically, you can write the definition. Universal set is a set that contains all set in a given context is called universal set. The set, collection of all sets which are into consideration, or that contains all the set in a given context. If you are talking about the boys and girls of a particular class, then all the students of a school, that will be called the universal set. If you are talking about some of the set of natural numbers, some of the set of integers, some set of rational, some set of irrational, so you can say set of all real number, that will be the universal set. Or you can say in simple definition, you can say which contains all the sets of in a given context. If you are talking about numbers, then all the set which contain all types of number, that will be a universal one. And you can say if you are talking about, let's say, coordinates, as I have discussed, like 1, 2, 3, 4, if you are talking about only 2 coordinates, but the set which contain all possible coordinates, that set is called the universal set. Or you can say one more example you can take, let's say if you take set A as 1, 2, set B as 3, 4, 5, 6, then universal set, which is denoted by capital U, that can be 1, 2, 3, 4, 5, 6, because it contains all the sets. It contains A also, it contains B also, so that is called the universal set. Getting it? Universal set? It is an easy one, which contain all the set in a given context, that is called a universal set and denoted by capital U. Just remember this one. Now the important one is this one, power set. This is the very important one. What do you mean by power set? So first note down the definition. Let A be a set, it can be any set. It means the collection of all subsets of A. The collection of all the subsets of A, that is called the power set of A. It is denoted by P of A. So whatever is the number of subsets, the collection of all those subsets, that will be the power set of A. And you know that empty set and the subset itself and the set itself are always the subset of any set. Then the power set of any set is always non-empty, because it always contain the empty set and the subset itself. Now let's understand with the help of example also. Let us take an example. Let's say A is equal to 1, 2, 3. Now first of all, understand this is a very important topic over here. This 1, 2, 3 are the elements of A, and this curly bracket indicate that they are in the roster form. Now what are the subsets of A if we have to write? Subsets of A if you have to write. So first of all, always remember that 5 will always be the subset. So we can write only single 5 we will write, and without any this curly bracket. Just remember this one, 5 is always written without curly bracket if we are writing about the element subset. Now second one will be this 1. 1 can be the subset because 1 is an element of A. So we can write like this, it can be written in the curly bracket, 1 is a subset of A. Then 2 is also a subset of A, you can pick any value. 3 is also a subset of A. We have taken the individual value. Now you can take the 2 values at a time. 1, 2, this is also a subset because why it is a subset? Because every element of this 1, 2 is also element of that A. That's why it is the subset. Similarly, you can write 1, 3. You can also write 2, 3. And one more important which we have left, that every set is a subset of itself. So the entire 1, 2, 3 is also a subset of itself. So the collection of all these are the subsets. So, or you can also check, like in A we have 3 elements, and if there are 3 elements, the total number of subset will be 2 power 3, which is 8, and these are the 8 subsets. Now if we make them into, again, is a collection, the collection of all these subsets, that is called the power set of A. So if you have to write it in the form of power set of A, we will put all these again in a curly bracket. So we can write it like this, curly bracket, and then again curly bracket, and writing all these subset as it is, 5, 1, 2, and separated by a comma also, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3. So if you are writing all the subsets in a curly bracket in one place, that collection is known as the power set of A, power set of a set. That is the meaning. Are you getting it? Shillong, Kohima? Okay. So if we have to write, like, let's say A is 2, 5, then what are the, we have to write the power set of A. So how we can write power set of A? Always remember, whenever you are writing power set of A, starting with a curly bracket, first of all, the first subset would be 5 without any brackets, then element 2, then element 5, and then element 2, 5, same. So this is the power set of A. So, and one more thing, if A is empty set, and I have told you how we can write that empty set. Either you can write that empty set is as 5, or you can write it as simple curly bracket without nothing. So either you can write like this. Then the power set of A, which is a it is no element, so this symbol will always be there because we are writing power set, and these has to be in these curly bracket. So you will write 5. Then power set of A is always denoted by this symbol, power set of any void set or any null set. Don't get confused in parenthesis, because this is a very important thing. If I am writing power set of A, you can see it has only one element, which is phi, or you can also write like this, you can see it has nothing. Nothing means phi it is. So these brackets are for the power set, and which element is there? Phi. So this will be the you can say power set of A. Similarly, if we are talking about, if I write the power set of A, so you can take one question that would be helpful in understanding the situation. Show that n times it means, if you are talking about from the beginning, power set of A, then again power set of that, and then again power set of that, and here n indicates the number of elements, cardinality. So the number of elements in this situation is going to be 4, that you have to show. And what is A over here? A is a void set or empty set. So we can solve it step by step. First, power set of A. Since A is a void set, then power set of A, it has only phi in the power set, right? Now if you are taking again the power set of this thing, so we are talking about power set of this phi, or you can also don't write like this, directly see power set of this thing we are talking about. Now it has one element, phi is the element, so we will write one of the element, phi will always be the subset. How many subset it will have? One phi will be there, and this element, this phi, you can see this phi and this phi are not same. This phi is of the empty set, and this phi again. So what I have done over here, you can see that earlier the A was having nothing, so in the power set the only phi was the subset, so we have written that subset in the parenthesis, curly bracket. Now if you are talking about this set, this complete set which we are getting in the first step, if you are taking the power set of the A, it means we are writing all the subset of this one. So first subset will be the phi, and this itself means I have written this complete thing over here, right? Now again, if we are taking the power set of this thing, so write it like this. Now it has two elements, you can see, one is phi and one is this phi which is in the braces. So first element you will write phi, which is the subset, empty. Then second thing, this element would be written, so this element is in the curly bracket. Then this second element would be written, and this second element will also be written in the curly bracket. So there will be double curly bracket, and then this complete thing, and this is the thing, and closed by the bracket. So these are 1, 2, 3, 4. 4 elements are there. Are you getting it, all of you? If you are not getting, please let me know, because this is a very important thing, how we can write the power set. So always remember, whenever you are writing power set is basically means the collection of all subset, and whenever you are writing the subset, point number 3, okay, I will explain you again. Subset is always written in the curly bracket, that you have to remember. You can write like this, make one point over here, we will discuss that example once again. Whenever we are writing element is always written without these curly braces, and subset is always written with curly braces, and for the element we use the symbol belongs to, and for the subset we use the symbol this. this one symbol. So again take the example, A is void set. So you can take it like this, this is a void set, right? So first if you are talking about power set of A, so power set of A basically means the collection of all, I am explaining once again Kohima and Shillong, just concentrate. A is the void set, right? So we can write it like this, only the curly braces without nothing. Now power set of A, if you are talking about this one, now you can see nothing is there in this one, so only subset would be the empty set. Empty set is always the subset of every set, so this is a null set, so empty set should always be there, so phi will be there, and these, you can see these brackets which I have placed over here, these brackets are for this P, this power, right? Now this set, this is the first step. Now in this first step, you can see in this power set of A, we have one element like this. Now if you take power set of this thing again, so first we will place these curly brackets in the starting and in the end. These has to be there always for the power set. Now between these brackets, we will write all the subsets. So first subset, this is the one element, so first subset is phi, and always remember that phi is written, if you are talking about the empty set, the phi is written without the curly brackets. So this is phi, right? And now the second element would be this phi, and this phi has to be written like this. So this is the curly bracket. So these are the two elements in the power set of A. Now in the second step, you can see in this power set we have the two elements, phi and phi with a curly bracket. Now again if we take the power set of this thing, so first there are two elements in this one. Now you will write phi will always be there, this phi, and now this phi we will take, this is first element, this first element would be written in the parenthesis, curly braces. Second element would be this one, it is already with the curly braces, but again we will write it in the curly braces, and the fourth one will be the complete thing itself, and the closeness of this one. These starting and these final are for this P, and in between I have written all the subsets of that one. Are you getting it now? So you can see there are 4 subsets. And when we will do some more example, it will be clear. I know this is, you can say in the starting it is a little bit difficult one to understand, like how to write the power set, how to write the subsets. When we will do more example, it will be clear to you. But 2-3 things you have to remember. This is the first point, that elements are written without this curly braces and we will use the symbol belongs to. Subset is written always in the curly bracket, use the symbol subset. And the third point you can also write over here, if phi is a subset, phi is written without curly braces if it is a subset. अगर वो already subset है, like phi is a subset of every set, so that is written without parentheses, like I have written here over, I have written here, I have written here, you can see. Let's take one more example. If A is equal to, this will help you in this one. We have to find power set of A. This will make your concept clear, because in this one we don't have any phi or something like that. We have the exact elements over here. So because that was phi 1, so phi बहुत सारे phi हो गए तो confusion हो सकता है. यहाँ पे थोड़ा कम होगा, because यहाँ पे आपको directly दिख रहे हैं, there are the elements A and B. Now, So if I have to write the power set of A, so always remember in writing power set, this starting and the last bracket will always be there. This is for this P. This thing you have to keep in mind. Second thing, always start with the null set. So phi, right? Just starting in the right phi. That is a subset of every set, and that is written without this parenthesis. Now, what is the first element? A. And how we can write A in the form of subset? With the parenthesis. Second element is B, with already there are parentheses, but we will write again it as a subset with the parenthesis, like this. And in the last, we will write the complete thing. This is the power set of A. Are you getting it? Shillong, Kohima? Okay, perfect. So let us do some of the examples that will help you more clear. So example 1. So we have the set, phi is a set, one comma 2, phi is one of the set, A, B and C. So we have to fill the symbol as either subset or not subset. We have to fill in the blank. Now think properly. Whenever you are using this symbol subset, you have to check whether the element on the left, whether if A is a subset of B, then every element of A has to be an element of B. So 10 seconds, fill it quickly, then we will discuss. And when you are done, just let me know. Okay. And Kohima done? Presidency, TETSO. If this is your first class, might be you are not getting that one if it is your first class. Okay. So let's discuss the first one. Always remember the first point, phi is a subset of every set, and if phi is a subset, we don't write the curly brackets. So phi is a subset of B. That is always true. So you can write like this, phi is a subset of B. Second one, for between A and B we have to fill. Now check whether all the elements of A are the element of B or not. You can see 1 is present in A and B both, but 2 is present only in A, 2 is not present in B. It means A is not a subset of B. We'll fill it like this. A is a subset of subset or not? 1 comma 2 and 1 comma 2 present in A and C both, so A is a subset of C. And for B, 1, 4, 8 are the elements of B, and 1, 4, 8 are the elements of C also. So you can say B is a subset of C. Getting it? Any doubt? Kohima, any doubt? Okay. Now let us take a very good example. This example will help you in clearing your concepts regarding that subset and element. So it will give you a better idea like how you can differentiate between whether it is a subset or whether it is an element. It's a very good example. So just based on the true and false, so I will give you some points and then you have to figure out whether the statement is true or false. So it will give you a better idea about the how to differentiate between subset and the element. So the example goes like this. If A is a subset given like this, so यहाँ पर ये जो subset A set लिखा है, इसका मतलब है कि what are the elements? So elements of A are 1, 2, this 3, 4 in the parenthesis, this is complete element and 5 is the element. If I say, okay, let's start with the question, then you will get an idea and you have to write true or false, okay? So 11 points are there. You just have to write true and false. So think wisely and try to do. When you are done, just let me know. Shillong so fast. Tetsu and Presidency College, can you give your responses? Are you getting it or not? Okay, done. So let's start with this one. So you can cross check yourself. Let's say one question is of 1 mark. 11 questions are there. So let's do the check the first one. First of all, check the symbol. In the first one, this symbol is subset. Subset symbol is there, and 3, 4. So 3, 4 is already present with the parenthesis in this one. And if you are writing subset, you remember that subset are written with the curly braces, but this 3, 4 is not written with the curly braces. So this one is false, because it is not written with the curly braces. There should be 2 curly braces outside this 3, 4. If we talk about the second one, the symbol is belongs to. This symbol belongs to means it should be a element, and 3, 4 it is directly present as it is over here. So 3 comma 4 is an element of A, this is true. Third one, 3 comma 4, this was the element as it is rightly present, but we have placed one of the parentheses again curly braces, then it becomes a subset of A. So this is true. 1 is an element of A. Element is written directly, as I have told you. So 1 is written directly, so fourth one is correct. But we cannot say 1 is a subset. If 1 has to be the subset, this one is false. Why? Because the symbol used is subset over here, and 1 is not the subset, 1 is the element. If we want to make this a correction in this one, if I write like this, then you can say this is right, because 1 is a subset, we have used the curly braces. Now again the symbol is subset, so 1, 2, 5, element 1, element 2, element 5, and they are written in the curly braces, so sixth one is true. Seventh, 1, 2, 5, element. Now you know that elements are not written in the curly bracket, this one is false. 1, 2, 3 is a subset. Now you can see that we cannot take 3 from that element. 3 comma 4 completely is an element. We can't take 3 outside of that one, or you can, if we replace 3 comma 4 by some other number, we cannot take something out of a given set. So 1, 2, 3 is not a subset. 5 is not an element of any set, so ninth one is again wrong. But 5 is a subset of A, and whenever 5 is a subset, this is written without curly braces, so this one is right. And again, since 5 is a subset, but this is written without curly braces, so this one is false. So these are the answers. So how much you got? Like if you are self-check, if you are on a self-check. Any doubt in anyone, or all of them were correct? Nine correct, okay. Number 8. Okay, Shillong, number 8. Yeah. See, here this is written 1, 2, 3 is a subset of A or not. Why it is false? This is false because of this 3. You can see that 3 is present combinedly with 3 comma 4. It is not present individually, like 3 is not an element. Elements are 1, 2, 5, and 3, 4 completely combinedly is an element. We cannot take 3 separately. That's why it is false. Getting it? If the question was like this, 1, 2, 3, 4, 5, then in that case, if the question is like this, 1, 2, 3, 4, 5, all are the elements, 1, 2, 3 separately and 4 separately are the elements, then you can say 1, 2, 3 is a subset of A. But if it is written like this, 3 comma 4 is in the parent, in the curly braces, you cannot take 3 out of that, then that's why it is false. And Koima, your 9 were correct, so which one were not correct? And if you have any doubt, please ask. Okay, no doubt. Okay, so let's take one more example like this. Okay. Now this time try to see that all of them should be correct. 10 parts. Just let me know when you are finished. Okay, Shillong, done. Okay, so let's start. First one, you can see C comma D with the is an element. This is not a subset, so this one is false. C comma D is an element. This one is true. Now this notation is right. Since we are using the symbol subset and this element is written with the curly braces, this one is right. A is an element of A, that is right. But A is not a subset, that is false. Then we have A, B, E. A, B, E are the separate elements and they are written in the curly braces. This one is a subset, that is true. A, B, E, if they are the symbol used is element, that's why we don't have to write it in the curly braces. This one is false. A, B, C is a subset of A. We cannot take C out of this combined CD. This one is false. Phi is a element. Phi is never a element, but phi is a subset. But if phi is a subset, that is not written in the curly braces. This one is false. If we take one more, phi is a subset of A. This one is right. How many are right? Oh, 10 correct. Wow. And Koima? Areva. That's great. Okay, let us take one more. इसको थोड़ा ध्यान से करना. Just after this question, we will take a break. Just one more question. Just after this question, we will take a break. Do it fast. True false बताना आपको. Okay, Shillong done. Koima. Okay, so let's start. It is talking about the element, first one. Phi is an element. This is true. This phi with a bracket, curly braces is already element. This one is also true. And this is using element, but in the question one is not present with the braces, and here we have used braces, so this one is false. Fourth one is a subset. 2 and phi are the subset written with the braces, true. 2 is a element of A, not a subset of A. This one is false. 2, 1 is not a, it is already written, it is not a subset. So 2 and 1, yes, it is not a subset because we have already placed. Why this is not a subset? Because of these braces. If these braces are removed, then it is a subset. So it is not a subset. It is already saying not a subset. So this statement is true. And then 2, 1 is not a subset. Yes, that is also right. Just because of these braces, this is not a subset. Then this is a subset. Phi is present as an element. This braces are present as an element, and this is present as an element. This is also true. And this is a subset. So this element is directly present over here with the braces over here. So this is a subset. So last 6, 7, 8, 9 are true. So how many were correct? Shillong, Koima. I hope all. Areva. And Shillong? नाइन करेक्ट. अच्छा 9 ही तो है. हाँ ठीक है. Okay, so let's take a break. After the break we'll continue. 10-minute break. Okay. Okay, welcome back students. So I hope यहाँ तक आपको समझ में आ गया होगा like what is the difference between subset and element and how the representation difference, that is the important thing. So starting with the next question. So are you all there? Shall we start? Okay, so just one example. Write all possible subsets of these. So you have to write all the possible subsets. Subsets for these and proper subsets of these. Subset of these and proper subset of these two. When you are done, just let me know. And Shillong, done? Okay, so subset. So first of all, only one element is there. So you know phi is a subset of every set and this element itself, right? And since one element is there, the number of subset is 2 power 1, which is 2. For this one, phi तो रहेगा और पहले तो 2 तो लिखी दो. These two will always be there. These two will always be there. Phi and the set itself. And now 1 and then 0. 4 subset. अगर इनको if we take the parenthesis curly braces outside these, this will become the power set. Now for this one, phi will be there. The same set will be there. This element 1 will be there with the braces, and this element which already has the braces, it will have again the braces. These are the subsets. And second one, proper subset. Now proper subset means which doesn't contain all of them. It means whatever is the total number of subset, just one minus, or you can say that set will not be the counted in the proper subset. So you can say proper subset will be 5, it will be 1, it will be 2, it will be 3, it will be 1 2, it will be 1 3, and it will be 2 3. 1 2 3 will not be counted because in this case that will become improper. And for this one 5 and only 5 ही रहेगा. Getting it, all of you? How many subset? If there are n elements, अभी हमने डिस्कस करा था, if there are n elements then the number of subset is 2 power n. So you can see in the first one only one element was there, so 2 subsets are there. Here we have 2 elements, so 4 subsets you can see. Here also we have 2 elements, so 4 subsets you can see. And the proper subset is 2 power n minus 1. So agar if there are 3 elements in this one, so proper subset will have 2 power 3, 8 minus 1, 7 subsets. And 1 element, so 2 power 1 minus 1, which is 1 proper subset, which is 1. Getting it, Shillong? Koima, any doubt? Okay. Now these are the questions in which you can find the answers or we can check. Now there are certain type of questions in this one in which we have to prove the given things, or we have to, you can say, give the reasons why it is true or why it is false. So for that type of question there is a standard approach, so we will discuss those questions now, what is the approach we can use in order to prove the statements or disprove the statements. So if you remember that when we were discussing subsets, if A is a subset of B, if I am saying A is a subset of B, then if X belongs to A, it implies X belongs to B also, right? Similarly, if B is a subset of A, then if X belongs to B, if X is an element of B, then we will say X is an element of A also. So using these two statements, if X is an element of A, if we do the inverse of this one, if X is an element of A, it implies X is the element of B, then we will say A is a subset of B. If X is the element of A, it implies X is the element of B, then we will say A is a subset of B. Or subset of B means we are talking about the proper improper subset, we are not talking about the proper one, because in proper subset we will not include that dash which is equal to. And if X is the element of B, it implies X is the element of A, then therefore B is a subset of A. If A is a subset of B and B is a subset of A, then we will say from these two we can say A is equal to B. So in order to prove that two sets are equal, what we will do, just note down this statement, this is very important in proving questions. In order to prove A is equal to B, we will show that A is a subset of B and B is a subset of A. If we can show that A is a subset of B and B is a subset of A, then we can say that set A and set B both are equal. And how we can show A is a subset of B? How to show A is a subset of B? So what we will do, we will take element X, therefore X belongs to A, and show that X also belongs to B. So this is the set algorithm. In order to prove two sets are equal, we will say that A is a subset of B. We will show A is a subset of B, and how we will show A is a subset of B? We will take one element, random element, which belongs to A, and using some methods, we will show that X also belongs to B. If X belongs to A and X also belongs to B, we will say that A is a subset of B. Similarly, to show B is a subset of A, we will take X belongs to B, and then we will show that X belongs to A also. It means B is a subset of A, and if we have shown these two things, we will say that A and B both are equal. This is the algorithm which we will use in proving that two sets are equal. So note down this algorithm. This is all very important one. In order to prove that two sets are equal, we will say both of them are subset of each other. That is the basic thing. And when we will do the questions, it will be more clear to you, like how we can use this one. Any doubt till now? Getting this? Okay. Or whatever theory I have written, because this theory is not important. Important is how we can proceed, use this in the question. And okay, now can you see in the corner, Shillong? If B is a subset of A, if you have to show B is a subset of A, we will say that we will take one element such that X belongs to B, and we will show that X also belongs to A. And this is the set algorithm by which we can prove that two sets are equal. And when we will do the sample questions, then it will be more clear to you. First of all, just note down whatever I am writing over here. Okay. Second thing, second concept you have to remember, there are two words which we use. One is the and second one is or. And generally we write it as small also, and or. So meaning of and is common, and meaning of or is union, or you can say total. So basically it says, if I say A is a set having these elements, right, and B is a set having element, let's say 3, 4 and 5, right. If I say write a set A and B, write the set having the elements A and B. So A and B, using this symbol and, you will see what are the common elements in both of them. So common elements in both of them is only 3. So A and B will be only 3. And if I write A or B, so you will see what is the total number of elements in that one without repetition. Make sure without repetition. So you can see the total number of elements are 1, 2, 3, 4 and 5. This is the meaning of and or. And means common thing, or means total, union. Are you getting the difference between these two, and or? Because we will frequently use these two terms, and or, in the later concepts. Okay. And Shillong, getting it? The meaning of and or? Okay, okay. Now, let's do an example. Suppose, question goes like this: A is equal to the question says, let A is a set having elements A, B, C, D, B is a set having elements A, B, C, and C is a set having elements B, D. You have to find all sets X, some collection of all sets X, such that X is a subset of B, a proper subset you can see, X is a subset of B and X is a subset of C. This and over here indicates that X is a subset of B as well as X is a subset of C also. It should be common to both of them. Similarly, second point says X is a subset of A and X should not be a subset of B. So first thing, you have to remember the notations over here. If I am saying the main thing over here, you can note it down as a separate thing. If X is a subset of B, right? So X is an element of power set of B. Agar X B ka subset hai, it means it is a subset of B. So it means X will be an element of power set of B. Power set of B means collection of all the subset of B. So if X is a subset, then X will be the element of power set of B. This is very important thing over here. If X is a subset of B, we can say then X is an element of power set of B. This concept we will use in solving this question. So we have to figure out all set X such that these two things. So it means X will be the element of power set of anything. So if X is a subset of B, we will figure out that what are the power set of B. Power set of B means set of all subsets of B, and X will be the element, X will be out of them. So you can say, you can solve it like this. So first 3 elements are there. So first let's say figure out all the power sets of these 3 things. So power set of A. So power set of A will be phi, then B, then C, then D, BC, BD, CD, and A is also left over there. It will be so many things because 4 elements are there. So A, B, C, D. No need to write all of them, just memorize this one. 4 elements are there, so they are going to be 2 power 4, 16 subsets are there. So I am not writing all of them, I am just writing like this. So power set of B, there are 3 elements, so we can write 8th thing will be there, which will be phi, A, B, C, AB, BC, AC, and complete ABC. And for power set of C, only 2 elements are there, so 4 subsets, B, this is D, and BD, right? So what I have done, I have just written the power sets because X will be the element of these power sets, because since X is a subset of B, so X will be the power set. Now using this one, so first thing it says, the question, first one question says X should be a subset of B and X should be a subset of C. So we can write this one, this implies that if X is a subset of B, we can say X is an element, this belongs to symbol means element is a power set of B and X is a element of power set of C, right? So, so you just have to focus on the power set of B and power set of C, because since it is written and over here, so just figure out what are the common elements in that one. So X belongs to, X is an element of intersection, or you can say X is an element of the common things of power set of B and C. So if you see in the power set of B and C, phi is the common element, this B is the common element with the parenthesis, and we don't have any other common element, you can see only phi and B are there. So X is an element of phi and B. X is the element of this thing. If X is the element of this thing, it means X will be either phi or B. This is the answer. Are you getting it? Shillong and Kohima? We just have figured out the common elements from the power set of B and C, because the AND notation is used in between. Kohima, getting it? Okay. The second part of the question was, let's do it over here itself so that you can relate. Second point was, X is a subset of A and X is not a subset of B. So it means if X is a subset of A, it implies that X belongs to power set of A and X does not belong to power set of B. X does not belong to, not a subset, it means X does not belong to power set of B. So X belongs to power set of A and X does not belong to power set of B. So we have to figure out what are the common things in this one. So you can see that we don't have to take the common things over here. So whatever is there in the power set of A, that should not, and what should not be in the power set of B, that we have to take. So like you can see phi we cannot take, because if you are taking phi is present in both of them, we cannot take phi. The B, we cannot take B because B is present in both of them. We cannot take C also, but this D, we can take this D because D is present, these are element of power set of A, but it is not an element of power set of B. So we can say that X belongs to this D. Second, BC we can't take because BC is present in both of them. BD, we can take BD. After, or we can cross check with this one. BD we can take, we can take. CD, we can take CD also. Then ABCD, because ABCD is not present in this one, so we can take that one also, ABCD. What is not present, what is not common, you can say AB, we cannot take AB over here, we cannot take this ABC, or whatever is left, like out of these things, whatever is left, just remove these three things from the power set of A, because A was having ABCD all the elements. So we can't take A and we can't take C. AB we cannot take, BC we cannot take, AC we cannot take, ABC we cannot take, but we can take BCD, we can take ABD, we can take, and AD we can take. So, and one more is left, we can take ACD, we have done, ACD which is left, ACD we can take. These are the things, these are the 8 subsets which we can take from the power set of A, because they are not present in the power set of B, which should not be present in the power set of B. So these are the 8 things. Or basically from the complete power set of A, just subtract the things which are present in the power set of B. These are the things which we can take. All of you are getting it? Shillong, Kohima? And Kohima, getting it? Okay, perfect. Suppose if the question is of proving like this, if ABC are 3 sets it says if A belongs to B and B is a subset of C, it is asking, is it true that A is a subset of C? If not, give an example. So we always have to solve these questions by taking the help of an example. A is a element of B, because A belongs to B means A is a element of B, and B is a subset of C. So we have to show whether A is a subset of C or not. And whenever it is written, if not, give an example, in 90% of the cases it is not. So what we can do, let's solve this one by taking an example. Let A is equal to 1. A is a set having 1, and since it says that A is a element of B, so this complete thing should be in the B like this. I'll take B2 also. So A is a element of B, we can say, because directly that thing is written over there. We have done element and subset, many questions we have done. So we can say A is an element of B, and since B is a subset of C, then this complete thing should be there. So we can write C as, since B is a subset, so without these parentheses it should be written like this. So now we can say that B is a subset of C. This type of example we can take. A is an element of B, and this is you have to work upon this one. This should be clear, like what is this element and what is this subset. This is very important in this question. So I have taken A is a element of B because I have written as it is in the B. Now since B is a subset of C, so or you can do it in the reverse way to check from C whether B is a subset or not. Take two elements from C and we have put the parenthesis. So when we are writing that B in the C without parenthesis, we have to write it like this. Then only we can say B is a subset of C. Now, is it true that A is a subset of C? So now can you see that A is whether A is a subset of C or not? You cannot, we cannot say A is a subset of C, because this one is a element. You can say that A is a element of C, right? You can say, but you cannot say A is a subset of C. When we can say A is a subset of C? When there is again double curly bracket over A, then only we can say A is a subset of C. Are you getting it? So in this case we can say A is an element of C, but A is not a subset of C. So like this we have to show. So therefore A is a subset of C is false. Are you getting it? Like how we can take these examples? Okay, again एक बार फिर से कर लेते हैं. आपको ऐसे एग्जांपल लेने हैं जो इसको सेटिस्फाई करे. पहला स्टेटमेंट है A is a element of B. First of all, you have to remember. So whatever A you are taking, let's say let's take another example. What we should take? Let's say 3, right? So A is a set having 3 as the element. Now this A completely is the element of B, because this belongs to symbol means A is the element of B. So we should write this complete A has to be present in B with these parentheses like this, and take another number, right? So now you can see that A is a element of B. Now it also says that B has to be the subset of C. If B has to be the subset of C, it means the elements of B, these two are the elements of B, these should be present in the C. So we can take C as this element, these two has to be present, and like one more element like this. So this is C. Now you have to check whether A is a subset of C or not. So you can see A is not a subset of C, because if A has to be the subset of C, there has to be double curly braces outside A. We can say A is an element of C, but A is not a subset of C. So A is an element of C, this is right, but A is a subset of C, that is wrong, because the 3 with the curly braces is a element of A. Getting it, Shillong? Okay, that's true. Now, let's do one more example like this. If X is an element of A and A is an element of B, then X is an element of B. We have to see whether this is true or false, and if it is true, it has to be true in all the cases, not in some cases. If it is false in any of the cases, it is false. This is the logic for proving something true or false. Like if whatever example you are taking, if this statement is true, this has to be true in all the examples you can take. But if it is false in any of the example, then it is always false. So let's check. So always what we have to do the negative way of this one. We will always try to prove this one as false. If we can't prove this one as false, we will say this is true. This is the way in which these questions has to be done. Getting it? What should be the logic? You should take that type of example in which you will try to prove these statements as wrong. If you succeed, then it is wrong. If you can't succeed, then it is true. Getting it, Shillong and Kohima? What I am trying to say? समझ में आ रहा है? मतलब आपको ऐसा एग्जाम्पल लेना है कि जिसमें आप ये हिंदी समझ में आती है ना, शिलोंग एंड कोहिमा? एंड कोहिमा? You understand Hindi, Kohima? Okay. So आपको strategy क्या होनी चाहिए? You have to take it like we will try to prove this statement as false, if possible. If we can't prove, then it is true, otherwise it is false. So X is a element of A. So you can take A as 1, right? So it means X is equal to 1. Since X is an element of A, so X is equal to 1. Now A is an element of B, so it means this complete thing has to be in the B with some other thing also. Let's say 2, right? Now can we say that X is an element of B also? So now you can see, okay, कोई फिर तो ठीक है. तो देखो यहाँ पर X is an element of A, so I have taken A as this set. So what is the element over here? This 1 is the element, right? X is an element, or you can say 1 belongs to A. 1 is an element of A, right? And A itself is an element of B. So it means this complete A with these curly braces should be present in the B, and I have taken one random number also like this set. Now using these two, can we say that X is an element of B since X is equal to 1? So 1 is the element of A. You can say that 1 is not an element of B because curly braces is an element of B, but alone 1 is not an element of B. Therefore X belongs to B is false. ये समझ में आ रहा है? So you can write like this. Clearly we can see 1 belongs to A and A belongs to B, but 1 does not belongs to B. Therefore, X belongs to B is false. Getting it, Shillong and Kohima? Okay. एक और एग्जांपल लेते हैं. If A is a subset of B and B is an element of C, then A is an element of C. We have to see whether it is true or false. So देखो, A is a subset of B. So how we can take this A? Let's say we have taken A as 1, right? This is the subset of B. It means जो B होगा, the element of A should be present as the element of B. So we can write B as 1, 2. 1 तो लिया ही है मैंने, 2, 3, 4, 5 randomly कुछ भी ले सकते हो. So I have taken 1, 2. So now you can see that A is a subset of B because the element of whatever element is present in A, which is 1, same element is present in B. Now B is an element of C. This complete thing should be present with the parenthesis, should be present in C like this. 1, 2, and let's take 5. कुछ भी ले सकते number आप. So this is the C. Now whether A is an element of C or not, can we say A is an element of C? You can say this A, this is alone 1 is in the curly braces, but here 1 is not present alone. Therefore, or you can say 1 belongs, you can write like this, 1 is an element of A is a subset of B, and B is an element of C, but you can say that A is not an element of C. By taking this example, you can say. Getting it? समझ में आ रहा है? Okay, that's cool. So that's all for today. So today we have discussed the power set, and please after going home, please revise this concept, like how to write the subset, how to write the power set, and how to prove these types of questions. These are very important one because एक दो बार आप practice कर लोगे तो ये बहुत easy हो जाएगा आपके लिए. So this is the important thing. And now in the next class, what we are going to do, we will do some of the questions from this class in the next class, and then we will start the Venn diagrams in the next class. So before that one, go through all the topics which we have discussed, and then we will study in the next class. Okay then, bye.